So, Pixel Police, we are building this protocol that enables organizations to verify whether any digital content, be it image or video, is not GenAI or Deepfake. So, citizen photojournalism has been picking up. We have been seeing it coming from war crimes and a lot of other places. They are sent to news organizations, but news organizations do not have any way to verify with the authenticity of that digital content, the digital media sent by these photographers and locals. This problem becomes even bigger in the Gen AI world, where any image could be generated from Gen AI. For example, in this image, which is a fake Pentagon explosion image which went viral, this affected the S&P 500 drop by 30 points and kind of affected the whole stock market a lot. And this gets even bigger in war crime zones. So, what's the solution? Pixel Police, which enables organizations to verify that an image is authentic, and you can basically trace back to the origin of the image using Pixel Police.
So I'm going to show the live demo, how it works. So here is a application that is being built using this rollup. So I'm going to open the camera app. And as you see, it asked me to enable the location. So what it does is actually takes the geotag or like location while signing the attestation, so that like later, just in case want to prove that this was captured from a particular location, especially applicable in war crime pictures. So I'm gonna take a picture of my friend. So I've just taken a picture, and if I like put it on attestation, so you can see the state transition would be happening. And yeah, so I have a picture now, and suppose I want to perform some operation which will happen under in the zkVM. So let's do maybe like a grayscaling. So I've just clicked on grayscaling, and the another state transition should happen. So yeah. Uh, so yeah, the state transition has been happened, and suppose now this image being sent to maybe a media portal, or let's click on share. Yeah, just media portal or any social media. So there should be a way to know like what this image is and what really it was, if in case it was edited. So let's see. So if you click on history, then you can see the actual history of the image and what type of operation has been performed on this picture. So yeah.
Yeah, let's just go a little deep into the architecture as we have seen the demo a little bit. So, in the architecture, what we have built is basically a rollup, and which can be like a specialized version of a multinodal app rollup instance. So, in the main entity in this particular rollup is the node itself, and the node itself like have like three different components: zkVM, rollup client, and the RPC server. The zkVM environment enables us to like perform arbitrary computations and get the proof of this arbitrary computation. So in this particular rollup, we have designed like our own like custom state transition function as well as state machines, which enables us to like perform edit operations on that particular image data. All the edit operation on a digital content are been happening in the zkVM environment, so that we can get the proof of the correct execution of those operation on that particular digital content. Similarly, we have like rollup client to facilitate state transition and like RPC server to like make necessary RPC call. So this is the high level overview of the architecture we have developed. And like similarly, this could be the state structure in this particular rollup might look like. Suppose we might have an origin image 0, 0, and someone basically took that particular image and does certain edit operation on top of it and built a 0, 1 version of it. And like someone else might take that 0, 1 version of it and like, make some edit and basically generates the proof of that particular edit and can generate like 0, 2 version of it. So in this manner, the state of a particular digital content will lie in this particular rollup.
So we basically, in the demo, we basically had a mobile application through which a citizen could capture an image and then send to any news organization, which could then be verified in our Pixel Explorer. Now, and very important question: will someone really adopt such kind of thing? So there's a standard called C2PA, which is currently being developed in collaboration with Adobe, Microsoft, and a few other companies. And the objective is that publishers, creators, consumers, all the stakeholders have the ability to trace the origin of different types of media. And we have done that for images. This is a standard that's still being developed, and so this attempt of ours at Pixel Police is one of the first implementations of this standard that can enable this. So imagine Adobe, Microsoft, and everyone leveraging a roll-up. That is one of the aims here. Uh, Other than news, there can be many other applications of the same. For example, social media platform where you can enhance trust and combat misinformation. Legal and forensic analysis where you can work on tamper-proof verification. Advertising and marketing where you can ensure integrity of the images. Uh, in terms of next steps that we think possible next steps is to integrate what we have built with the C2PA standard, work with Adobe, Microsoft, BBC, etc., to get this out there, and probably also build a SDK for editing and camera apps like Adobe Photoshop. So yeah, that's from our end.